All right. Hey, chemists. In this last video of our notes here, we're going to be determining a molecular formula from empirical formula data, percent composition, putting it all together. So earlier we compared empirical formulas molar mass to the molecular formula's molar mass, and we saw that there was a whole number integer between them. So here's methanal, which is a 1 to 2 to 1 ratio, and ethanoic acid, which is a 2 to 4 to 2 ratio. This is a multiple, or if I multiply by 2, I will get the molecular formula. So CH2O times 2, I get C2H4O2. The same exact thing for the molar mass. If I multiply its molar mass by 2, I get the molar mass of the molecular formula. Or I could see that 60 over 30 is equal to 2. The molar mass of my molecular divided by the molar mass of my empirical gives me that integer that I'm multiplying by. So let's keep that in mind. The molar mass of the molecular divided by the molar mass of the empirical gives me the integer multiple in which to multiply by. Now, it may look like they're different formulas and they have different molar masses, but both these compounds have the same percent composition. Look at the calculations of the percent composition for methanal, CH2O, and ethanoic acid, C2H4O2. Hydrogen is 6.7%, oxygen's 53.28%, carbon's 39.99%. But look at C2H4O2. Hydrogen is also 6.7%. Oxygen's also 53.28%. And carbon is also 39.99%. The same percent composition. The same. What's different is the molar mass and the number of each atom. But why do both of these compounds have the same percent composition? Well, it's because their mole ratios are the same. Like if I had another compound that was C6H12O6, it would have the same percent composition where percent hydrogen would be 6.7, percent oxygen would be 53.28%, and the percent carbon would also be 39.99%. It would be a multiple of this. So, in order to determine the molecular formula when you have an empirical formula, you must be given a molar mass of the molecular formula. You have to determine the molar mass of the empirical formula, and then divide the two to see how many times larger I need to multiply by empirical by my molecular. So let's look at like a quick example here where I give you the empirical and I give you the molar mass. Calculate or determine the molecular formula of a compound whose molar mass is 60 grams per mole. So I got a molar mass of a molecular probably. And the empirical formula is CH4N. Well, we wrote before that if I want to figure out like how many times larger my empirical is than my molecular, I need to divide by some molar masses. So let's get the molar mass of CH4N. We've done something like this already. Well, that means that for this compound, there's one carbon, 4 hydrogens, 1 nitrogen. Carbon is 12 grams. Hydrogen is 1 gram. 1 times 4 is 4. Nitrogen is 14 grams. 14 plus 4 plus 12, that's 30 grams per mole. This is the molar mass of the empirical, and I'm already given the molar mass of the molecular. I could already see that that number is twice as large. If I couldn't see it, I'll do my math of molar mass of molecular divided by the molar mass of the empirical just to see how many times larger it is. So 60 divided by 30, and I get 2. So now how do I get my molecular formula? Well, I take this number 2 and I multiply it by all of the subscripts in my empirical formula. 2 times 1, 2 times 4, and 2 times 1 again. That will give me C2 H8N2. This is my molecular formula. You could also check and see that its molar mass is 60. It is. You got 24 and 8 and 28. That's 60 grams per mole for my molecular formula. Putting it all together, this is what a problem would look like, and this is how I'm going to end this lecture. You'll be given the percentage of each element in a compound. You have to determine the empirical formula. You'll be given the molar mass of the molecular formula, and you'll have to get the molecular formula. So let's do this question together, and then you'll be ready for your practice. So, percent composition data can be used to determine the empirical formulas. You will need the molar mass to determine the molecular formulas. So here we go. We got 62.1% carbon, which is 62.1 grams carbon. We got 13.8 grams hydrogen from the 13% hydrogen. And we got 24.1 grams nitrogen from the 24.1%. We're going to divide by their molar masses quickly here. So 62.1 divided by 12. Just got to plug this into a calculator. So 62.1 divided by 12. And I get 5.175 moles of carbon. I could divide by 1 gram for the hydrogen here, and I get 13.8 moles of hydrogen. And then finally for nitrogen, 24.1 divided by 14 grams, and I get 1.721 moles of nitrogen. So that's steps 1 and 2. My third step is dividing by my smallest moles. Between the three of them, it looks like my 1.721 is my smallest moles. So I'll divide each of these by 1.721, divided by 1.721, divided by 1.721. This gives me 1 nitrogen, 13.8 divided by 1.721, this gives me about 8 hydrogens. And then this top one, 5.175 divided by 1.721, this gives me about 3 carbons. So there, before my eyes, are my empirical formula, C3H8N. Now, let me get its molar mass, because I have to compare it to the molar mass given here. This is the empirical. Now I got to get molecular, just like I did before. The molar mass of this is, 12 times the 3, plus the 8, plus the 14. This molar mass is 58 grams per mole. So you're going to have to trust my math on that one. Well, the molar mass I was given was 174. So let's see if I could try and figure out the molecular formula. I would be doing 174 divided by 58. And I get 3. So I'm going to take this 3 now. That means that my empirical formula, if I multiply and have 3 units of it, I will get my molecular formula. So I'll do 3 times the C3H8N, 3 times C3, 3 times H8, 3 times N, and I'll get C9H24N3. And that will be my molecular formula. And that's it. This signifies the end of our unit here. This is the last thing we had to learn. This was determining empirical and molecular formulas